Hello, I am Neha and I am going to discuss the topic of diode. Diode. Diode is a semiconductor device that allows flow of current in only one directions. Now the question arises, what are semiconductors? Semiconductors are the materials that have conductivity between conductors and insulators. Examples like silicon and germanium. There are two types of semiconductor. First is intrinsic semiconductors and second is extrinsic. Intrinsic are pure semiconductors while extrinsic are doped semiconductors. Now what is doping? Doping is basically the addition of the impurities into the pure semiconductors for the purpose of modulating its electrical, optical, and structural properties. When we add trivalent impurity to a pure semiconductors like boron and aluminium, then p-type semiconductor is formed. Like here we can see that silicon is replaced by boron. Boron can form three bonds, so there is a vacancy, and this vacancy is called holes. When we add pentavalent impurity like phosphorus and arsenic to the pure semiconductors, then N-type semiconductor is formed. Here we can see that silicon is replaced by phosphorus, and phosphorus have 5 valence electrons, so there is one free electrons, and this present in the void and conduct. Now how we can construct the diode? We can construct the diode by joining two equivalently doped p-type and n-type semiconductors. How the diode is going to work? The p-type semiconductor has excessive holes and n-type semiconductor has excessive of electrons. As we can see here, this is n-type and this is p-type. Now this is the zoom version of this. Now, here we can see that due to difference in concentration of charge carriers in the two regions of the p-n junction, the electrons from the n region diffuse through the junction into the p region and holes from p region diffuse to the n region, and the motion of the charge carriers give rise to diffusion current across the junction, and after some time an equilibrium is reached. And after the equilibrium is reached, there is no further movement of holes and electrons. Here this is the depletion region after the movement of electrons and holes. Now here, when an electron diffuses from n region to the p region of the p-n junction, it leaves behind an ionized donor atom in n region having positive charge which is immobile. Similarly, when a hole diffuses from p region to the n region of the p-n junction, it leaves behind an ionized acceptor atom in the p region having the negative charge which is immobile. As a result, an electric field is induced and it acts like a fictitious battery, and this is potential barrier. Now how the diode is going to bias? We can bias the diode by connecting it to the battery. There are two types of biasing. First is forward and second is reverse. In forward bias, P side is at higher potential, and in reverse bias, N side is at higher potential. Now in forward bias, we can see that the applied voltage is going to oppose this barrier potential, so this depletion region is going to decrease, while in the reverse bias the applied voltage is going to support this barrier potential, so this region is going to increase and the current become approximately equal to 0. Now there are some applications of diode. First is light emitting diode. It acts in the forward bias. When we apply a sufficiently forward bias, then the electrons present in the conduction band come to the valence band for the purpose of to combine with the holes, and there is some release of energy in the form of light. Now next is the rectification. Diode can also act as rectifier. It can convert alternating current to the direct current. There are two types of rectification: half wave and full wave rectification. In the half wave rectification, when the applied voltage is positive, then due to induction, the positive is created here and the diode become forward bias and we get an output, and the output implies input. While in negative half cycle, this diode become reverse bias and it offer infinite resistance and it act like an open circuit. So we get no output. V output is equal to 0. The output waveform of a half wave rectifier is a pulsating DC waveform. In the full wave rectifier, we can see that we connect two diodes D1 and D2. In the positive half cycle, D1 become forward bias and D2 become reverse bias. So we get an output due to D1. While in negative half cycle, D1 become reverse bias and D2 become forward bias. So we get an output D2 D2, and we can see that the full wave rectifier convert both halves of AC signal into a pulsating DC signals. Diode can act as a voltage regulator when it is reverse bias. Now we can see that VI characteristics of diode. We can see that in reverse bias, diode has a unique feature that the voltage drop across it is independent of the current flow through it. When the voltage applied is greater than the breakdown voltage, then it acts as a voltage regulator. Here we can see it. Now there are some other applications of diode. First is the diode can act as protection circuit. It can protect the devices which are very sensitive to the reverse bias current. Diode can act as a switch. In forward bias, it is in the on state, and in reverse bias, it is in the off state. Now, coming to the conclusion, we know that the basic building block of all modern electronics is the semiconductor chips. Semiconductors are integral part of our life. These are heart and brain of automobile industries and medical devices. India and the world has bright future in it. So, thank you.